We are back at it. I told you more examples were going to come your way in this video, and that's what you're seeing on the screen right now. A, B, C, D. And with each one of these, it says, give me two names. Give me the IUPAC name. Give me the common name. Okay, well that's fine. We've done videos. We've done examples. We know how to do this. Hopefully I'll feel comfortable with them. Let's see. So let's start with A. All right, with A, we're going to start with the IUPAC names first. We're going to name everything using the IUPAC system. And then after that, we will then go through and name everything using the common name system. All right, so IUPAC is going to be first. Okay, A, longest carbon chain, 1, 2, 3, 4. So, butane. Number closest to the right-hand side, because that's closest to my chloro group. It's the only one on there. 1, 2, 3, 4. So at carbon number 2, I have a chloro group. 2-chloroputane. There's your name. Ding, ding. You got it correct. See how easy and quick and painless that was? Next one, B, IUPAC. Longest carbon chain, this cyclohexane ring. All right, so cyclohexane. There we go. I only have one group. That group's a bromo. And you know what? I've got the freedom because it's a ring where I can start the numbering wherever I want to start it on the ring. And because there's only one group and that one group's a bromo group, I'm going to put my number 1 right there. Makes it very convenient, doesn't it? 1 bromo cyclohexane. Correct. You just got it. I told you organic didn't have to be that hard. And hopefully these examples are proving it. Next one, longest carbon chain. 1, 2, 3. I can go longer. 1, 2, 3, 4, 5. All the way across. I can do 5. And that means that this is a pentane. Well, here's the story, folks. If you did 1, 2, 3, 4, 5 all the way across, good for you. That's your 5-carbon chain. If you did 1, 2, 3, 4, and then go down to number 5, good for you. There's your longest carbon chain. You get the same answer no matter what. Don't believe me? Try it. So, 5 carbons. This is going to be a pentane. Well, I've got 2 groups. The first group is here, and that's your chloro group. The second group is here, and that's your methyl group. And we often said that the halogen takes the priority whenever we have a clear-cut choice like this. So because of that, I'm going to start numbering on the side closest to the halogen. And this is the side closest to the halogen here. So this is going to get carbon number 1, carbon 2, carbon 3, carbon 4, carbon 5. All right, so on carbon 1, I'll have a chloro group, and on carbon 4, I'll have a methyl group. So the name of this structure is 1-chloro, 4-methyl pentane. And there you go. There's your IUPAC. Next one for part D, we're going to IUPAC it as well. This one, they give me a skeletal structure. I have to understand that that is a carbon, that is a carbon, and this is a carbon. So I've got a 3-carbon long chain here, and that is called a propane. So on carbon number 2, no matter how I number it left or from the right, it's the same number, 2 each time. On carbon 2, there is a fluoro group. So 2-fluoropropane. There are the IUPAC names for examples A, B, C, and D. All right, now, the directions do tell me give 2 names for the following. So they do want both, which represents IUPAC and common. So I'm going to have to go through and I'm going to have to give you the common names of this thing as well. All right, so how do I do this? Well, keep in mind, common names do not use IUPAC rules so much. They use things like isos and sex and terts. Those are the things that they kind of use. So I just got to keep that in mind. They also name the structures a different way. They kind of forcefully put the halogen name at the end, like we saw in our previous video. So they make the order a little bit backward. So let's just kind of do some examples, and A, B, C, and D are going to be really good ones where we can just bring in the common nomenclature once more. So this chlorine is actually attached to a secondary carbon here. And this, because of that, is going to be a sec-butyl. That's how we always start off the common names. And then we add on the "-ide" ending with the halogen. So this is going to be chloride. Sec-butyl chloride is what that's going to be named as. Keep in mind that secs really stop at 4 carbon chains. When I get to a 5th carbon chain, I've got choices, and sec-pentyls really cannot be an option for me. And the reason is because there's 2 different types of secondary carbons. There's one toward next to the last, and then there's the one in the middle. And a name has to be very obvious on what structure. And if I'm not careful, I will not know what secondary carbon they're talking about. So secs really are going to be used for the butyl groups most of the time. Okay, for part B, how do we name this one? Well, this one's going to be pretty easy. I'll name the carbon ring first with a YL. So this is cyclohexyl instead of cyclohexane. And then for the BR, this is going to be bromide. So cyclohexyl bromide. Notice they just flip the order of these things. That's all that they do. So cyclohexane has been moved toward the front, and we call it cyclohexyl. And then bromo gets moved to the back, and this has an ending change that we call bromide, not bromo. Next one for C. C here, well, if we take a look at C, it looks like we have that L group there at the very end, don't we? Right here, this L group, CH3, CH, and then it points down to CH3. We know that this is going to be called the iso group. So that's a very good place to start here with a common name, iso something. So how many carbons in total? 1, 2, 3, 4, 5, 6. Therefore, this is called isohexyl. And then Cl is our halogen, so this is going to be called isohexyl chloride. And then for part D again has this L-shaped. I know that it's not drawn like this, but I could if I wanted to. CH3, CH, I could point that CH3 down and put the F right here. If that helps you see it a little bit better, then that's no different than this up here above. They're just writing it in a different direction. That's all that they're doing. But this F is in the middle of a 3-carbon ring. So this is also an iso, and it's an isopropyl because there's 3 carbons in total. And the ending of this guy is going to get fluoride, isopropyl fluoride. Okay, now we're not done with the question yet because it also says indicate whether each is primary, secondary, or tertiary. All right, so this chlorine is attached to this carbon. That carbon has 1 to the left and it has 1 to the right, which means that this is a secondary carbon, which means that the halogen is also a secondary halogen. So that's how we determine that, all right? The Bromo group is attached to this carbon. This carbon has a carbon to the left and it has a carbon to the right. So therefore, this is a secondary carbon, which means that this is a secondary halogen. If I go to part C, this chlorine is attached to this carbon, and this carbon only has 1 other carbon that it's attached to. So this is a primary carbon, which means that this is a primary halogen that we have in the structure. And then for part D, we do the same reasoning. This F is attached to that carbon. We have 1 to the left. We also have 1 to the right. And because of that, this is a secondary carbon, which means that this is a secondary halogen. So just once more, going back, taking a look at some of those older rules and definitions that we brought up to the table a little while back in a couple of videos, and they are just reconfirming that process all over again. All right. So there's some more examples of naming halogens, how to name them IUPAC IUPAC, how to name them a common way. We try to stay away from common, once again, whenever we can, but sometimes these are there, sometimes we can't get rid of them, and that's just the way that it is. And we have to accept that fact, right? So here is where this video is going to stop. It's going to be one of my shorter ones, believe it or not. And the reason is because we're getting ready to talk about a different type of group. And the next upcoming group is going to be an ether. So I need to talk about how to name the ethers. That was a functional group that we introduced earlier on, and we have to learn how to name those the proper way. So that's what we're going to start in the next video. It's really a different kind of lecture topic in a way, so because of that, I'm not going to make it bleed into this one. So I'm stopping this one here. In the next video, we'll come back, we'll take a look at ethers again, we'll take a look at their structures, and then we'll take a look at how to name them. And we'll name them both IUPAC and commonly.